Okay, we're gonna do this lesson, which is dividing a polynomial by a binomial. And it's very similar to long division. Okay, so I'm going to we haven't done long division in a long time. So I'm just going to give you a refresher on what long division is. Okay, I'm gonna make up some number 4,576 divided by 22. Okay. And the first thing you have to do, hold on a second. Okay, so the first thing you have to do is figure out how many times 22 can go into 4. Well, it can't go into 4. 4 isn't big enough. So then 22 can go into 45 2 times. 2 times 22 is 44. And 45 minus 44 is 1. And then we have to bring down the 7. How many times can 22 go into 17?
0.
0. We cannot forget to put the 0 right here. 0 times 22 is 0. 17 minus 0 is 17. And then we bring down the 6. How many times can 22 go into 176? Well, I know 20 can go in 100 5 times. And I know 20 can go into 60 3 times.
8, 7.
So we're going to try, I'll try 8 first. Oh, and look at that, 176. It goes in there evenly. Okay. All right. Now, what happens though if I would have divided 23? Let's try 23. Okay. 23 can't go into 4. So we're not going to even put a number above 4. Okay. 23 goes into 45. 1 time. And when we have 22 left over, so I'm going to bring down the 7. Okay, so 227. Again, I know that 20 goes into 105 times. So I'm thinking it's going to go in there 9 times. And that is correct. So 207. And then I subtract. And I bring down my next number of 6. Now 23, so I already know 23 times 9 is 207. So it's going to have to be 8 because 207 is too big. 184, okay? And, oh wait, no, that's 2. That's 2 with 22 left over. Remember though, if you have a remainder, a lot of times in middle school, you would add a decimal and you would keep going, right? But today we're going to actually do remainders. Okay, we're going to solve using remainders. So this one would be 198 with a numerator of 22 and a denominator of 23. So my final answer would be 198, 22, 23rds. This would be my final answer. Okay. So we are going to do this long division, but we're going to do it with variables. Okay. So let's go to our notes. Okay, the very first thing that you're going to want to do with these problems is make sure that they're in standard form, going from descending order with the degree of each term. Okay, in this case, we already have it here. Now, when you set up this long division, you're going to have to set it up like you do here. Okay, so I am going to show you the first one. Not right now. And then you guys will practice the second one. Okay, so I'm going to have 2x squared minus 6x plus 10. And I always write it like this to remember which number goes on the inside and which number goes on the outside. Divided by x minus 2. Okay? So that's how you set them up. Now, our very first step is figuring out how many 1x's can fit into 2x squared. How many 1x's can fit into 2x squared? Okay. Is it about this?
Wait till I answer. Can I go to the bathroom?
Not right now. Okay, so I know that 2 of these can fit in here. So what I'm going to write up here is 2x. Okay. And that's for this 2x squared. Now, the one difference between this and the long division is that because 2x times x is 2x squared. So what you're trying to do is you're trying to find a factor up here that when multiplied by the x will get you your first term right here. Because like terms are above each other. So if you look at this example, like terms are above each other. And that's what I was going to say a minute ago. That is the one difference between regular long division and this type of long division with polynomials. Okay, so see what I do here. 2x times x is 2x squared. 2x times a negative 2 is a negative 4x. Okay. Yes.
Why did you bring down the x?
Say that again.
Why did you bring down the exponent?
What exponent? This one? I have to multiply 2x times this whole term. Really, what I'm doing is I'm taking 2x times x minus 2. Because look, when we did our long division right here, once we figured out how many times 22 could go into 45, we said it was 2. You had to multiply these two terms to get this down here. So that's what I did here. I said, okay, x can go into 2x squared 2x times, and then I multiply it. So you end up, when you multiply this, you get 2x squared minus 4x, and that goes right below this.
Oh.
Mary, did you have a question? Okay. So once you get a term up here, you have to multiply it by both terms right here.
Wait, so you wanna
Get both.
get the number?
You want to choose a term right here that when multiplied by this first term, the x, will equal this.
It's always gonna equal the first.
Yes, with what we're doing. Now, any other questions before I show you the next step? Okay, I'm going to show you that right now. So the next step that you're going to do is you're going to subtract this whole thing. Okay, but do you remember what happens when there is a subtraction in front of the parentheses?
Oh, all the signs flip.
All the signs flip, or basically you're distributing a -1 to every term. So I'm going to change this to addition, and I'm going to take 2x squared minus 2x squared and -6 plus 4x. So you're flipping the two signs because you're subtracting them. So when I subtract this part, I get 0. And then when I combine these terms, I get a -2x. Yeah. Okay, but I want to make sure everybody gets that part. Okay, the next thing we're going to do is we're going to bring down our +10. Okay. And we're going to start over. So look at our division here. Once we figured out that 22 goes into 45 2 times, we get 44. 45 minus 44 is 1. We bring down our 17. Then we have to figure out how many times 22 can go into 17. That's our next step. How many times can this x go in this -2x? basically, what am I going to multiply x by to get a negative 2x? Negative 2. So it's going to be up here. I'm going to write a minus 2. And notice my 2 goes above the 10 because they're like terms. So now I'm going to multiply negative 2 times this. So if you can't do it in your head, you could do it like this. So negative 2x plus 4. So negative 2x plus 4. And now I have to subtract those, which is the same as adding the opposite. Okay, for those of you who are just sitting there, you really need to be paying attention. All right, so I'm going to change this to addition and flip the signs inside the parenthesis, and I could go ahead and subtract. Okay, now this one happens to have a remainder. Okay,
Do you always flip the signs like that?
yes.
Okay.
So this remainder, since this is a positive 6, I'm going to put plus 6 over x minus 2.
Wait, why do we?
Why did we change this here? Okay, let me show you something. We had, and I want you guys to pay attention to this because you may not have to flip them if you get the concept here. We have negative 2x plus 10, right? And then we had negative 2x plus 4. Okay, and what we had to do is we had to subtract these two. Okay, so if you can understand that we're taking a negative 2x minus a negative 2, which is the same as negative 2x plus 2, that's 0. And then a 10 minus a positive 4, which is 6, then you don't have to change the signs if you understand what we're doing. But the reason I have you change the sign is because sometimes people will forget that instead of subtracting this 4, they will end up adding it, and that will be wrong.
But why do we subtract?
Just like in long division right here. Wait, just like in the long division right here, 45, we subtract the product of 2 times 44. Every time we're subtracting. So every time here, we have to subtract. But I take I change it to adding the opposite because sometimes that's easier for students to read. Because it's a binomial and we always forget to carry that subtraction to the second term in the binomial. Any other questions? Okay, I know that this is kind of a complicated concept. So we're going to do this other practice one right here or this other example here. And then I want to see if you guys can go a little bit further with the examples. Okay. So let's do this one. So we're going to take x cubed plus 6x squared plus 8x plus 13. Notice that there are more terms. Instead of a trinomial at the top, we have a binomial. I mean a polynomial. Okay. Okay. So how many x's can fit in x cubed? Or x times what gives us x cubed? Yes, to make this x squared. So we're going to put an x squared here. And then we're going to multiply. X squared times x is x cubed. X squared times 5 is 5x squared. Okay. And now I'm going to subtract it. So x cubed minus x cubed is 0. And then 6 minus 5 is just x squared. Or you could change this to adding the opposite. I don't know, I missed it.
It was the dojo place.
Okay. Any questions on that step? Okay, we're starting over.
What?
Wait, what?
Oh, no. I mean, we're starting over with the whole process. We're gonna bring down the positive 18. Okay, and you really don't need this 0, by the way.
Wait, you said, why'd you put 18?
Oh, it's an 8, sorry. 8x, yes. Okay, so x times what is gonna give us x squared?
8.
X times 8 is gonna give us x squared.
X.
X, okay, so x times x is x squared. X times 5 is 5x. And now we have to subtract. So I'm going to switch my signs. 8 minus 5x is 3x. And now what do we do? Bring down the 13. Okay. Last time. X times what gives me 3x?
3x squared.
3.
Was there 6 problem?
3 times x is 3x, and 3 times 5 is 15. And now we have to subtract it, and we end up with a -2. So the way that you would write this remainder is just like we did in example 1. This is a -2 though. Since it's a -2, we're going to do minus 2 over x plus 5.
Wait, can you go up? I think I missed the first one. The first one, I think I missed the first one.
Okay, hold on. Are there any questions about this one before we try one on our own? Okay. So right now I want everybody to try practice 1 on your own. I'm going to give you a couple minutes and we'll do it together.
I guess it's
So don't forget that sometimes you'll have to write this in standard form. So instead of writing it exactly like this, you needed to write it as 2x squared minus 7x minus 9. Okay, so x goes into 2x squared 2x times, because 2x times x is 2x squared. And 2x times a -4 is a -8x. Okay, now we're going to subtract this. 2x squared minus 2x squared is 0. They cancel each other out. Okay. -7 minus -8 is the same as -7 plus 8. And you end up with just 1x. And you could just put x if you want. And then I bring down my -9. X goes into x 1 time. 1 times x is x. And then 1 times -4 is -4. And I will subtract these, which becomes a -5 right here. So my final answer is 2x plus 1 with a remainder of -5 over x minus 4. Okay. Any questions on that?
Let me get this. No.
Okay,
So,
what I want, hold on just a second. What I want you guys to do is to attempt practice 2, and then I'll go over that as well. Okay, so in this one, x goes into 2x cubed. How many times?
2x squared.
Yes, 2x squared. So then two x squared times x is 2x cubed. And then 2x squared times a -3 is -6x squared. Okay. All right, these cancel out. -17 plus 6 is a -11x squared. And then we bring down our positive 48x. Okay. X goes into negative 11x squared, negative 11x times. Negative 11x times x is negative 11x squared. Negative 11 times the negative 3 is a positive 33. And we bring down our x. Okay. Now we're going to subtract these, which is the same as adding their opposites. Okay, so these cancel out. 48 minus 33 is 15x. And then, do you need me to stop?
Oh, no. I added.
And then bring down the negative 45. Raise your hand if you need me to slow down.
Oh, yeah, just like a tiny bit. No, keep going.
No, I just.
But if you attempted this before I put it up here and you need me to pause, I will. But if you didn't even attempt it, I'm not doing this for you just to copy it down, okay? X goes into 15x, how many times?
15.
Plus 15 times. 15 times x is 15x, and 15 times negative 3 is a negative 45. Look at this one.
No remainder.
Yep. There's no remainder, so this right here is your final answer. Make sure on your homework that you are boxing in your final answer, okay? If that means you need to rewrite it, rewrite. Okay, let's flip it over. I am going to show you now how to solve some problems where you have a coefficient in your divisor. So we're going to set this up like we would any other problem. So 18x squared plus 6x plus 3 divided by 4x plus 1. Okay, how many times does 4x? I think that should be an 8, not an 18.
8.
Then my whole equation changes.
Sorry, it should be an 8. I'm sorry, so take off that one. So how many times does 4x go into 8x squared? 2x times. Because 2x times 4x is 8x squared. Remember, your goal is to match this one. Okay, and 2x times 1 is a positive 2x. Okay, now we're going to subtract this. And these cancel out, and you're left with 4x, and you bring down your positive 3. And then 4x goes into 4x one time. Okay, and you end up with a remainder of 2. So your answer is 2x plus 1 plus 2 over 4x plus 1. Okay. I want to show you something really quick on the warm-up. If you look at our warm-up letter D here, I asked the question, how would you write the remainder of 3 in this problem? So notice that whatever your remainder is goes on top of your divisor, which is x minus 2.
How do you say it was x plus 2?
Okay. I would like for you, do you guys want me to do one more with you or want to try one on your own?
Let's do one.
Okay, I want you to try practice 3 on your own. Okay, so this is your answer for practice 3. Check my work, make sure I didn't make any mistakes.
Oh.
Yes. This is my final answer right here.
Oh, that's the final.
Mhm. Okay. Go ahead, if you didn't get this right, figure out what your mistake was. And then we're gonna move on to example and practice 4. And I believe that these two you can try on your own. But is there anyone who wants me to do example 4 with you or
I
you?
think I kind of did.
Okay,
Yeah. No, we got it.
okay.
And,
So I want you to try these two on your own right here. Example and practice 4. When you get down to example and practice 5, they're a little bit different. But that doesn't mean that you couldn't do them. Practice 5, there is an additional step though. So I want you to wait until, I don't know, I'd have to.
I mean, it's only one lesson. This one.
Okay,
Oh,
never mind.
hold on, got to go back to my. Okay. So example 4. Two x to the 4th plus 3x to the 3rd minus 23x squared minus 12x. This is a long one. Okay, 2x goes into 2x to the 4th, x to the 3rd time.
Are you doing example?
I'm doing example 4. So that we get 2x to the 4th plus x cubed or 1x cubed. Okay. Now we're going to subtract. So now we have 3x cubed minus 1x cubed is 2x cubed. Bring down our negative 23x squared.
This is all it's doing. Yes.
All right, 2x goes into 2x cubed, 1x times. And plus 1. No, x squared times, yeah, sorry. 1x squared. So we subtract. And we get negative 24x squared and bring down our negative 12x. And 2 goes into negative 24x squared times negative 12x times. Right?
Yeah.
Negative 24x squared minus 12x. And when we subtract that, it actually becomes 0. So this one has no remainder. Okay. So any questions on that one? Yes.
Practice 4, it's not a 5.
No, it's not a 5. So we're going to make this. I want you guys to change this negative 7x to a positive 13x.
13.
Yes,
Right on 9.
sorry.
I must have been wrong.
Hold on just a second. Okay, so with practice 4, we did not need to change this middle number, and this is your final answer. Okay, example 5, you're going to notice that the numerator is not in standard form, and so you have to put that in standard form before you divide. So you should have x minus 4, and then x squared minus x minus 20. And then you can start dividing. So x goes into x squared x times. Oh.
Say what?
And then x minus 4 is a negative 4x.
What are we doing? Negative x?
Sorry.
And then you end up with 3x here, and you bring down your negative 20. X goes into 3x 3 times. And then you subtract. And you have a remainder of negative 8. So your final answer would be x plus 3 minus 8 over x minus 4. Okay,
That's really nice.
Please. That's not nice, bro.
okay. So for example number 5, in the numerator, they go from x cubed to just a whole number without any variables. and you can't divide, you need to make sure that you're filling in the x squared and the x. So this is how you would set this one up. It would be x cubed plus 0x squared plus 0x plus 1. So you have to put in the fillers of any exponents that are missing from your first term to your last term. Okay. And then this would be x plus 1 on the outside. Once you do that, you can divide like normal. And so I was looking on your homework, and examples in your homework that are similar to this would be the last two problems, 21 and 22. So when you're doing your homework and you see a problem like this, refer to this problem in your notes to help you. So I'm going to go ahead and divide. X goes into x cubed, x squared times plus 1x squared. And then we have to subtract. And then you get negative 1x squared when you subtract, and then you bring down your 0x. X goes into a negative 1x squared and negative 1x times. So,
Write it down a little bit.
oh yeah, sorry. So we're going to subtract this. And we get 1x, and then we bring down our 1. X goes into 1x times 1 time. And when we subtract it, we get no remainder. So this is our final answer right here. And that concludes lesson 6.11.